Hello, now we are going to talk about inverse of a matrix. If we have a matrix A and there exists another matrix X such that A matrix into X matrix is equal to X matrix into A matrix and that is equal to identity matrix, then we can say that X is an inverse of A. We also can say that A is invertible. Now since XA is equal to AX is equal to I, the matrix A is also an inverse of X. That is, A and X are inverses of each other. Now a very important property is that a square matrix has an inverse only and only if the determinant of A is not equal to 0. Square matrix A is said to be singular if determinant of A is equal to 0 and non-singular if determinant of A is not equal to 0. A matrix has a inverse if and only if it is non-singular, that is determinant of A is not equal to 0. Now we have important property that a matrix cannot have more than one inverse. That is, the inverse of A is unique if it exists. Now we have an important note that if the product A inverse B is defined, it is usually quite different from B A inverse because matrix multiplication is not commutative. Now to find the inverse, suppose we have a matrix A as defined here, then determinant of A is AD minus BC. That is, determinant of A should be not equal to 0. Then if we have a matrix A defined as this, then the A inverse is equal to 1 upon determinant of A, that is AD minus BC, into D minus B minus C A. In this case, what we have done is replaced the diagonal elements and change the sign of non-diagonal elements, as we can see here. Now if A x is equal to I, then x is equal to A inverse, and if y a is equal to I, then y is equal to A inverse. Now coming to some properties of inverse, if A and B are invertible n into n matrices, that is they are square matrices, then A minus 1 is invertible, that is the inverse of A is again invertible, and that is equal to A. Second property, if AB is invertible, then AB inverse is equal to B inverse into A inverse. We have to be very careful that we have to write the inverse in this very order, not the other way around. To repeat it again, AB inverse is equal to B inverse into A inverse. The third property states that the transpose of A, that is, we can also denote transpose by these two ways, that is A raised to power T or A dash rather. The transpose is invertible, and the inverse of transpose is equal to transpose of inverse. This is a very important property which says that the inverse of the transpose is a transpose of the inverse. Suppose we have a number C that is not equal to 0, then CA inverse is equal to C inverse into A inverse. Here A is a matrix and C is a number that is not equal to 0. The inverse of a symmetric matrix is also symmetric. Now to find a relationship between the minor cofactor and inverse, we need to first know the definition of minor and cofactor. So if we have a determinant like this, and if we delete row I and column j to arrive at a determinant aij of order n minus 1, then this determinant is called a minor. Now if we multiply the minor by the factor minus 1 raised to power I plus j, we get cofactor. And now suppose we have a matrix of cofactors and we transpose this matrix of cofactors, then we get the adjoint of A. As represented by this formula, we can see that we have a matrix of cofactors which is being transposed, and that is equal to adjoint of A. Now this leads us to the following theorem. Any square matrix A with order n into n, that is, it is a square matrix with determinant A not equal to 0, that is determinant of A is non-singular, then we have a unique inverse A minus 1 satisfying A into A minus 1, that is A inverse, equal to A inverse into A is equal to identity matrix, which is given by A inverse is equal to 1 upon determinant of A into adjoint of A. If Determinant of A is equal to 0. There is no matrix X such that AX into XA is equal to I. That is, their inverse does not exist. Now, to recall the definition of adjoint, we say that it is a transpose of cofactors. Cofactors are obtained by minors, which are obtained by deleting the ith row and the jth column, and to obtain a cofactor from a minor we multiply it by minus 1 raised to power I plus j.